So here we are with another question. So the question is that we have to find the area of a parallelogram whose adjacent sides are represented by the vectors 2i cap plus j cap plus 3k cap and I cap minus j cap. So again, this is an important application of cross product or vector product. See, we have already discussed it, but let's just again revisit that concept. Let us say we have two vectors, b vector, okay, we are shifting it laterally here. Then we have another vector, let's say a vector, okay, this a vector, we will also shift it laterally if we want. Let us not do that, otherwise it will be blank. So same thing, we will be drawing this. Let us keep that here, b vector, here, and we will also shift this a vector laterally towards the right side to get this vector, a vector, here. So these are the adjacent sides of this parallelogram, okay, a vector and b vector. All we did, we shift the a vector to the right, b vector to the top without changing their angle. Now if we extend this like this and this distance from the base of the parallelogram between these two parallel vectors b vector and b vector, that will be the height of the parallelogram. This angle again will be theta, corresponding angle theory, and this h, it will be a vector modulus sine theta, because sine theta is equal to h by a vector modulus, magnitude of a vector. So h will be a sine theta. Now area of parallelogram is given by product of base and height. Here base is b vector modulus, simply b. So area of the parallelogram will be b into a sine theta, which is equal to ab sine theta, which is nothing but the magnitude of the cross product of the vectors, the magnitude of the cross product of the vectors, which is this. If the angle is directed in this direction, then this will be the cross product. C vector is equal to a vector cross b vector, and that magnitude, C vector magnitude or a vector cross b vector magnitude, will be the area of the parallelogram form. So here simply we have to find out the magnitude of the cross product, okay. So here for doing that, we have to find out the determinant I cap, j cap, k cap, 2, 1, 3 and 1 minus 1, 0. 1 minus 1, 0. A vector cross b vector, that is equal to I cap into 0 minus 3, okay, minus j cap 0 minus 3 plus k cap minus 2 minus 1, which is equal to 3i cap plus 3j cap minus 3k cap. This is A vector cross B vector. Now the magnitude of A vector cross B vector is equal to 3 square plus 3 square plus minus 3 square root over, which is root over of 27 equal to 3 root 3 square units. This is the answer, this is the result. So basic application of cross product. Okay. So here is another question again on the same concept. The adjacent sides of a parallelogram are represented by 4I cap minus j cap plus k cap and I cap minus 3j cap plus 2k cap, these two vectors. We have to find out the area of the parallelogram. So again the same thing. So here the area of the parallelogram will be the magnitude of the cross product of the two vectors. Let us call this as A vector, this as B vector. Simply that will be AB sine theta. So first we have to determine the cross product A vector cross B vector. I cap, j cap, k cap, 4 minus 1, 1, 1, minus 3, 2. That will be I cap minus 2 minus 3 minus j cap 8 minus 1, k cap minus 12 minus 1. So that will be I cap minus 2 plus 3, which is 1, minus j cap into 7 plus k cap is 12 plus 1 minus 11. Okay. So it is I cap minus 7j cap minus 11 k cap. So A vector cross B vector modulus will be 1 square minus 7 square minus 11 square root over, which is 1 plus 49 plus 121, 50 plus 121, which is root over of 171 square units. This is A vector cross B vector, and this is the modulus of that, and this is the area of the parallelogram. Okay, the same concept, area of the parallelogram where two vectors are the two adjacent sides. It is simply the magnitude of the cross product vector. Okay, this. So first we evaluated the cross product and then its magnitude. Okay.